The curve with the equation y equals x to the fifth plus 20x squared minus 8 passes to the point P where x equals -2. Let's find the second derivative at the point P. For that, we need to find the first derivative, and then we'll have to take this derivative of that to get to the second derivative. So that's going to be 20x cubed plus 40. Now we're going to plug in x equals -2. -2 cubed is -8. And then 20 times -8 is -160. And so this is going to be -120. Now we want to see whether P is a maximum point or a minimum point. For this, we're going to use a second derivative test. Now recall the second derivative test is for the critical point. But here, the critical point is not x equals -2. So we're going to use this logic though. But anyway, so the second derivative test says if the second derivative is positive, you have a minimum. If the second derivative is negative, you have a maximum. Here we found the second derivative was a negative, and so we say that this is a maximum point. Now let's find an equation of the tangent to the curve at the point where x equals 1. So for a tangent line, you need a point and a slope. So let's say the point we want is x equals 1. Now the y value, you just plug in x equals 1, you get 1 plus 20 minus 8. That's going to give you 13. For the slope, we have to plug in x equals 1 in the first derivative. So that's going to be 5 plus 40 is 45. And so from there, we just do the point slope form, which is y minus 13 equals 45 times x minus 1. Here we'll simplify 45x, and then we have 45 times -1 is -45, plus 13 will give me -32. And so my tangent line is y equals 45x minus 32.